Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video demonstrates how to construct sampling distribution tables in StatCrunch. Let's get started. So typically you're going to have these problems that ask you to form probability distribution tables for sampling distribution and ask you some questions that are related to that. Typically, they give you a small population from which to sample. In this case, we're going to look at a population that has three numbers, 2, 4, and 8. We're going to take these numbers two at a time to take our individual samples and then calculate a sample statistic for each one of those samples that we took from our population. We're going to be selecting with replacement. So every time we take a number out, we put it back in so it can be selected again. First, we're going to be asked to find the value of the population standard deviation. Next, we're going to ask to find a probability distribution table for our sampling distribution of standard deviations. Here in this example, I'm showing you how to do this with standard deviation, but keep in mind that the procedure is pretty much the same whether you're asked to find a sampling distribution for means, variance, median, whatever it may be. The only difference in the procedure is when you come to calculate this individual sample statistic for your individual samples, you're going to have to use whichever sample statistic is specified in your problem. Other than that, the procedure is pretty much the same. Third, we're going to be asked to find the mean of the sampling distribution for the sample standard deviations. And fourth, we're asked if the sample statistic targets the population parameter. Let's take a look at how to solve each one of these parts of the problems separately in StatCrunch. So the first part of our problem asked us to find the value of the population standard deviation. Normally we just take the numbers in and just put them in column statistics, but because that's not the data that's actually imported into StatCrunch when we dump our data in, we need to add in an additional step, and that is to just put those population values into a separate column so that we can actually calculate our sample statistic for the population there in StatCrunch. So in this case, the data that gets dumped in when I click that icon on my problem is going to be looking like this, but then I just take the next column over and just manually type in. It's a small enough sample, so it's not that big of a deal. I'm just going to type in the individual values for that population. So then I can just go into sample statistics with stat, summary stats, columns, select the new column where my data was just typed in. And in the list of sample statistics for standard deviation, I don't want the one at the top. The one at the top is an adjusted standard deviation based on sample size. What we want is the unadjusted standard deviation because we're asked to find the population standard deviation. So I'm going to want to scroll down towards the bottom of my list of statistics and select unadjusted standard deviation. I press compute, and there in the results window comes the actual population standard deviation that I'm looking for. Now the next part of the problem asks us to construct a probability distribution table. And here's the part where a lot of students just kind of throw their hands up in the air. You don't know what to do with it. But let me show you how easy this is. Once you understand what you're doing, it's really not that hard to get. So our data is there in StatCrunch. We're going to go to Stat, Summary Stats, Rows. And in the options window that pops up, I'm going to select the columns, here where my data is located. And then I'm going to select standard deviation. Notice this is the one towards the top of my list of statistics, because we're actually calculating this for the sample, okay, for each of the samples. So I want a sample standard deviation. That's the standard one we've been using at the top of the list. I go ahead and press compute, and out comes this lovely little results window with the standard deviation for each sample that was in each row. So for the sample in the first row, my standard deviation turns out to be 0. That's probably because both of those numbers are the same. Then in the second row, the sample for the second row, here's my standard deviation, so on and so forth. Now it's going to be a lot easier for us to construct our population distribution table, if we have this data sorted. So to do that, I'm going to press this little arrow right here at the top, and that's going to sort my data from smallest to largest. Now I have what I need to actually construct my probability distribution table, and we can just go ahead and just do that. Let me show you how that's done. So here I have my results window, and here's a blank probability distribution table. So the first number that's going to go in the column is going to be that lowest number there that's listed first. So the 0 is listed first, so I'm going to put that here for my random variable. To calculate the probability, I'm going to get the part over the whole. So what's the part? How many zeros do I have? Well, I've got 3, and there's 9 values total. So the part over the whole is then going to be 3/9. I can actually reduce that to 1/3, and so that's what I'm actually going to do. I'm going to reduce that to 1/3 and put 1/3 here in my answer field. The next number that goes in is the next one that's listed in my results window, which is the 1.41. That's going to go here. I place it in the next position. What's its probability? Well, there's 2 of them out of 9 total, so 2/9 is my probability. And I'm going to do the same thing for the other values that I see there in my results window, and that's all there is to it. There's my probability table. Now if I want, I can run a cross-check on my math by adding up the numbers together for the probabilities. Remember, that's a property of a probability distribution, that those probabilities should add up to 1. And indeed, when I add them together, I see that they do equal to 1. The third part of our problem asks us to find the mean of the sampling distribution of the sample standard deviations. So I'm going to go back to my results window and press Options, select Edit. So I can go back to my Options window, and I'm going to select that checkbox there at the bottom next to Store in Data Table. What that does is it puts the results into my data table instead of a separate results window. I need to do this because only the values in the data table can I have to calculate statistics with. So I'm going to have to put those data values here. It shows up in the next available column. Then I can just go into Summary Stats, Columns, and then select this column and then do the standard deviation for that particular column. And then that comes out to be my value that you see there. The last part of the problem asks, do the sample standard deviations target the value of the population standard deviation? Well, what we're asked to do is to actually compare values, okay? And because our sample size is kind of small, sometimes the number that you get for the population is going to be a little different than the number you get for the sample, for the mean of the samples rather, even though you're looking at an unbiased estimator. And so that's why I recommend that students memorize that list of biased and unbiased estimators so they can use that in answering these types of questions. But essentially all you're going to be doing is just comparing numbers. So here's the number we got from our population standard deviation. Here's the mean of the sample standard deviations, and you can see that the numbers are not anywhere in the same neighborhood. And so therefore we would conclude from this that the sample standard deviation does not make a good estimator of the population standard deviation. Again, like I just said a moment ago, the samples you're going to be looking at with these problems are rather small. So there is that possibility that for an unbiased estimator, you'll see what you're seeing here. The numbers you're comparing aren't in the same neighborhood. So you need to make sure that you memorize that list and use that list when answering this question, because that's going to be the right answer every time. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.